So we're doing the third and final method, which is the method of elimination. Okay. So again, you are given two equations right here. Okay. So when you hear the word elimination, what comes to mind?
Someone dying.
Someone dying. Okay. Get rid of. Okay. Good. That's what it means. So step one, choose which one you want to get rid of. Is the X dying or is the Y dying?
Why actually? Kill them all.
Kill them all. Okay. So violent. Okay, so looking at here, I want to get rid of the X. Why the X? So in this case, let's say I want to get rid of the X. Alright. Second step is make the coefficient in front of the variable by the same lowest common multiple. So notice right here, this is 2x and this is 2x. So the number in front of the x is already the same. That's what you want to do. Right? So in this case, it's already done for you. Okay, so you want to make again. What does the word coefficient mean?
The variable.
Not the variable, but Kevin, which number?
What's the one in front of the
The one in front of the variable, right? Okay, so the number in front of the variable in this case is both 2. That's what you want. Okay, so to get rid of the x, should you add or subtract? This is 2x, this is 2x. Yep. Subtract, that's right. So in this case, we're going to subtract because 2x minus 2x gives us, cancels it out. Okay, so 2x minus 3y equals 5. I'm just rewriting the two equations here. All right. And as we said, we're going to subtract the two equations. All right. Yes, that's what we're doing. Okay, so Tayden, what is 2x minus 2x? 2x minus 2x? Yeah, that's how you get rid of it. They're gone. Just like what we were trying to do. Done, gone. Okay. But then what is negative 3x minus 2y? Think about it. You're moving further away down the line. Yeah, Andy?
Negative 5y.
Negative 5y. And then what is 5 minus 10?
6. What?
Layla? Negative 5.
Oh, it's negative 2. Got
it. Okay, so when you subtract the equation, remember you're subtracting every term like this. Okay, that's okay. Right. Alright, so if you didn't see it at first, that means somebody else in class didn't see it as well. So negative 3y minus 2y gave you negative 5y. Okay. So from this step, you should know what to do. Y equals 1.
3 by 2. 1. 5.
Y is. What do you think I should do to find x? William?
Y is 1 for x.
Yeah, it doesn't matter which one I do. No, because it's an intersection point, which means it will go into, it's the intersection point for either line. So let's substitute y equals 1 into this first equation. Again, doesn't matter which one. Okay, so 2x minus 3, I'm replacing the y with a 1 now. And then it goes back. Okay.
He's just standing, that's it.
Okay. I was just wondering. Okay. So then 2x minus 3 times 1, 3. How do I solve for x now? Resman? Right, so it becomes 2x equals 5 plus 3, which is 8. And then last step, divided by 2, x equals 4. Alright, so what's my final answer? Gavin? 4, 1. Right. Okay. Okay, so take a look. Do you like method of substitution more or method of elimination more? Okay. But even though at the end you do have to do substitution too. Okay. So okay. So let's try another example here. Okay, so example 2. Since it's example 2, it's one extra step. Okay. Find the intersection point of the following system. Okay, you have the first equation. So I'm gonna rewrite my two equations so that it's on top of each other. It's a little easier to see whenever you do elimination. Okay, so these are my two equations. The first step, choose a letter to get rid of. Gavin? X. Okay. Second step, I have to make the coefficient the same. So my coefficient here is 2. My coefficient here is 1. Are they the same? No. So what do? Excellent. I can times the whole equation by 2 so that I get 2x plus 2y equals 10. Right? This one, I don't have to do anything, so I just carry it over. Yep. I'll wait. Okay, so what I did was I multiplied this whole equation by 2 so that the coefficient will match. Okay. Cool. Okay. So to get rid of the 2x, should I add the equations or subtract the equations? Subtract them. Right. So 2x minus 2x, that's gone. What's negative 3y minus 2y? Negative 5y. 5 minus 10? All right. And so y equals 1. Doesn't this look a little familiar? It's the same question, okay? It is. Because if you take a look at here, 2x plus 2y equals 10. X plus y equals 5. Alright, so okay, back to this. So as I said, it's the same. It's actually the same. So then when you substitute back into either equation, you'll see that x is 4. And then you're 4 and 1. Okay. Now, what do you notice about example 1 and example 2? What are these two linear systems called? So, in the first example, I had 2x plus 2y equals 10. And in the second example, the equation was x plus y equals 5. Okay? These are called equivalent linear system because they are just multiples of each other. When I graph it on a graph, I'm just going to get the same line. Okay, so they're actually the same. Okay. So what if you look at these two? 2x plus 4y equals 8 and x plus 2y equals 8. What is the solution to this? Okay. Yeah, so it says in this little box right here. Okay. If you compare these two, what do you notice? Yeah.
Same thing.
Right, they're the same thing. They're just multiples of each other. So when you graph it, again, you're just going to get the same line. So equivalent linear equations. The difference between like system and equation is just the system is like the set of two equations. And then equation is just equation.
Uh,
Yeah.
Sorry, I just remember. What is the test this week?
I'll get to that in a second. Okay. So
It's the last thing.
okay. There's there is something that I want to mention as well. Okay, so wait, don't skip the thing yet. Okay, so let's say I have something like this, two lines that cross each other. How many point of intersection is there?
One.
One. So there's one solution. One point of intersection is the same thing as saying one solution. What about this? Okay. What if I have two lines that never cross each other? How many solutions do I have? Andy?
Zero.
Zero. So there's no solution because they never cross. Okay. What if I have this line and this line where what we were just talking about? When we graph it, we get the exact same line. How many solution is here? Ming Yan?
Infinite.
Infinite number of solution. So this is infinite because every single point is crossing each other. Infinite solution. Okay. I actually want to go through one more example. I don't know why I think I left a page out by accident. Uh, okay, sorry. I have to do an example. Write it somewhere. I don't know why. I think I'm missing a page. Um, let's do